CrunchIT 3.0 is a web-based statistical software program provided by W.H. Freeman & Company.
CrunchIT 3.0 is very easy to use and utilizes R in the background. Let's take a quick look at CrunchIT in action.
When you first open CrunchIT, this is what you'll see. Data will go in the spreadsheet and all the goodies are in the menus. Your first step will typically be to input some data, and there are several ways to do this. To load data directly from your textbook, select Load From.
To demonstrate CrunchIT, we'll use data from the Basic Practice of Statistics, 5th edition, or BPS 5e.
For example, here's the data from Exercise 6 of Chapter 2 of BPS 5e. These are data on the weights of 19 Dallas Cowboy defensive and offensive linemen. The first column shows the position of each player, and the second column shows the weights in pounds. Since there are two position types, we might want to look at the distribution of weights by position. Sounds like a perfect job for the side-by-side box plot. To create a side-by-side box plot, we select Box Plot from the Graphics menu, then select the Grouped tab. Our data are the weights, and we want to group by position. I'll add a title to our plot, and there's our picture. Let's also compute descriptive statistics by position. I again select the Grouped tab, then it's just like we did for the side-by-side box plots. Summary statistics for defensive linemen here, offensive linemen there. In BPS 5e, Chapter 4, Exercise 29, we have data on behavioral loss aversion. There are two variables, neural and behave. Briefly, neural measures activity levels in a specific region of the brain, and behave measures individuals' sensitivity to loss. A scatter plot would be handy for exploring the relationship between the two variables. Let's make one. To create a scatter plot, we select Scatter Plot from the Graphics menu. Let's put neural on the x-axis and behave on the y-axis like this. And there we are. One natural analysis task to perform would involve the correlation between neural and behave. We compute the sample correlation in CrunchIT by selecting Correlation from the Statistics menu. We see that the variables have a sample correlation of about 0.85. Note, though, that this individual is a bit of an outlier with values of both neural and behave much greater than everybody else. So we might consider the impact on correlation of excluding this individual from the analysis. Without the extreme individual, the sample correlation drops to about 0.7. We might also wish to do linear regression with these data, treating behave as the dependent variable and neural as the independent variable. We do this by selecting Regression, then Simple Linear from the Statistics menu. I'll include the outlying individual just for fun. Here are the results, with a statistically significant slope estimate of about 0.009, indicating a strong linear relationship between neural and behave.
So as we've seen, CrunchIT makes it easy to load and work with data. The powerful R software is running in the background, but with CrunchIT, the student can focus on the content rather than the details of the underlying technology.